the second unit in our book. And this whole unit, we're going to be talking about graphing all sorts of different types of graphs and functions. So we start out with hopefully something that's a long time review for you. Been doing this for a little while, but we'll spice it up with a few different types of things. Um, Learning target 1, use the distance formula, and then learning target number 2, use the midpoint formula. So, and the third thing is be able to graph functions using ordered pairs. We will come up with much more sophisticated ways of graphing later on in this chapter, but for now, for this lesson, we'll be using ordered pairs. All right, so what are some of the vocabulary things that you'll need for this lesson specifically? Well, the Cartesian coordinate grid. Hopefully you know what that is. This is just the good old traditional XY grid. And we have 4 quadrants. This spot right here, this is called the origin. And then that gives us 4 quadrants. The first quadrant is this one right up here. And so just like if this were a number line, this would be positives and this would be negatives. If we were going vertically, up would be positive and down would be negatives. So in the first quadrant, all of the x values are going to be positive, and we would also be going up, so all the y values would be positive. As we move around, in the second quadrant, so we always go counterclockwise here, okay, you can see that the x values would be negative and the y values would be positive. Moving down into the third quadrant, okay, you can see that the x values would be negative and the y values would also be negative, so everything is negative. But here in the fourth quadrant, well, we would see that the x values would be positive while the y values would be negative. Okay, so this is the Cartesian coordinate grid. The Cartesian coordinate grid is made up of something called ordered pairs. Okay, you can even see here I had to cheat when I was describing the positive and the negative aspect. I'd say the x value first, then the y value. And so I can describe any location on the Cartesian coordinate grid using an ordered pair. Now, one of the things we'll be doing here is, between two ordered pairs, there's going to be a midpoint. And there is a midpoint formula. It goes a little something like this. X sub 1 plus x sub 2 divided by 2, comma, y sub 1 plus y sub 2 divided by 2. Okay, you can think of this as like mid being middle being like average. And what we're doing here is essentially finding the average x value. I add up all my x's and divide by 2, because that's how I find average. I divide by the number of numbers I have. And then I find the average of the y's. Let's see, I can also find the distance between two ordered pairs on the Cartesian coordinate grid. It also has a formula. It's going to be big old long square root. Then I'm going to say x2 minus x1. So if I subtract the x values from each other and then square them, then add this to doing the y values, same thing. This is going to get me the distance in between the two of them. Now, where does this come from? Well, if I just did a quick little thing here, well, you can see here that the distance between these two, well, it'd be kind of like I could make a right triangle. And how would I find the horizontal distance? Well, I would subtract the x values, and that's where this would come from. And, well, to get the vertical distance, I would do y2 minus y1. I would subtract the y values. And, well, we know that we can find the hypotenuse using the Pythagorean theorem. So this would be kind of like A, this would be like B, this would be like C. And so I have essentially A squared plus B squared equals C squared. But C is the distance, and so to get rid of the squared, I take the square root, and that's where the big long square root comes from. So there's where both the midpoint and the distance formula come from. You're going to need both of those for today. All right, let's see. Real simply, let's Go ahead and find the distance between these two things. Well, let's see, distance is going to be equal to, well, let's subtract the x's. It really doesn't matter the order. I usually go, so I don't wind up with negatives, but it really wouldn't matter if you did, because when you square something, it's always going to become positive. And let's see, let's go ahead and do the y's now. So I'll do a negative just to show you that it still works out. So negative 2 minus 4 squared. Well, let's see what happens. So this was 3 minus negative 8. 3 minus negative 8, well, that'd be like 11, so 11 squared. And then negative 2 plus 4, that would be, or sorry, negative 2 minus 4, this is a minus sign, would be negative 6 squared. Well, 11 squared is 121. And, well, negative 6 squared is positive 36. And so, what I'm going to do now is I'm going to go ahead and I'm going to add up my two values here. So 121 plus 36 is 157. And there we go, square root of 157. All right, the other kind of basic version here is, again, find the midpoint of the segments with these two endpoints. So remember, think midpoint, you want to think average. So I'm going to find the average of my x's. So 8 plus negative 6 divided by 2, comma, and then find the average of my y's, negative 4 plus 1 divided by 2. And, well, let's see what we wind up with. 8 minus 6 would be 2. And negative 4 plus 1 would be negative 3. So my final answer here, the midpoint, is going to be 1, negative 1.5. All right, so that's kind of the basics. Hopefully you remember that from previous math classes. Here's the ways that we would potentially kind of make this more complicated. So it's got 3 coordinates here. We've got negative 2, 5, 12, 3, and 10, negative 11. And we want to know, are these the vertices of a right triangle? Well, if they were a right triangle, well, let's just kind of like graph these out real quick. Then well, here, we'll just see what it looks like. Negative 2, 5. Negative 2, 5 would be somewhere up here. And then we've got 12, 3. So 12, 3 would be somewhere over here. And then 10, negative 11 would be down here. Okay, so if this were to be a right triangle, okay, well then this distance squared plus this distance squared would have to equal this distance squared. I think if this were going to be a right triangle, then this would be the right angle in question. And so that's what we're going to do. We're going to say this squared plus this distance squared has got to equal this distance squared, which means that we've got a lot of stuff going on. So we've got m, we've got n, and we've got q. Okay, and so we're going to say the distance, let's do mn first. Okay, so I've got the big square root of, well, let's see, maybe we'll skip a few steps here. We've got 12 minus negative 2, which would be 14. So 14 squared, and then plus 5 minus 3 would be 2, so 2 squared. This would come down to, let's see, 14 squared plus 2 squared, or 14 squared plus 4 would be 200. So I've got the square root of 200. Let's go ahead and find NQ now. Well, NQ, 12 minus 10 would be 2, so 2 squared. And then 3 minus negative 11 would be like 3 plus 11, so that'd be 14. So 14 squared, hey, look at that. It's going to wind up being the same thing over here, square root of 200. Okay, so if I took this squared plus this squared, it should equal MQ squared. Well, let's see, NQ, I've got 10 minus negative 2, or 10 plus 2, which would be 12, so 12 squared. And then 5 minus negative 11, 5 plus 11, that'd be 16, so plus 16 squared. Well, let's see, 12 squared plus 16 squared, that's going to be 400. So, bottom line, is this squared plus this squared going to be equal to this squared? So we'll kind of write that one out as 200, square root of 200 squared, plus the square root of 200 squared, going to be equal to the square root of 400 squared. Well, I think you can probably all see here that this cancels out each one of these, and is 200 plus 200 equal to 400? And the answer to that is, of course, yes. And so we can confidently say that this is a right triangle. All right, let's see, I think in the interest of time, I think we're going to just kind of skip over here. This one right here are the points, this, and this collinear. I guess what I want you to know about collinear points is that if you had, this would be more distance formula stuff. If you've got these points right here, okay, if they're collinear, meaning that they're all in the same line, then the distance, so P, Q, and R, the distance of the segments has to be equal to the whole thing. If you remember the segment addition postulate from geometry, that would be the case. So if you find the distance here and find the distance here, and that winds up being the same as the whole thing, PR, then that's enough to show that they are collinear. All right, let's see. So moving on to learning target 3, graph functions using ordered pairs. So right here, I've got what appears to be a rather complicated function. So find some ordered pairs. Well, let's see. So my ordered pair, usually we do this with a table. Oops. Okay, so draw yourself a little table here, and we usually have x is the independent, y is the dependent, and so you know, pick yourself a few values. And well, let's see, 0 seems like it'd be safe. So if x equals 0, I would wind up with 0 equals the square root of y minus 1. And when I solve this, you know, I just square both sides, and now I've got 0 equals, well, y minus 1. And so I add 1 to both sides, and y equals 1. So when x equals 0, y equals 1. If I were to graph, and again, this is not a great way of graphing, but I could say I do have a coordinate at 0, 1. All right, but that definitely isn't going to be enough for us to be able to graph it. So let's pick a few others. What would be another easy one to pick? Well, how about 1? 1 equals the square root of y minus 1. So again, I square things. 1 squared is 1, and then I've got y minus 1. So I add 1 to both sides, so y equals 2. So when x equals 1, y equals 2. So if I go over 1, I'd go up 2. Again, that's not really enough to tell me how much it is. So I don't know, let's pick at least one more. Maybe that'll be enough to tell us what it could look like. So, well, how about 2? Why not? What does y equal when x equals 2? So I take the square root, I got y minus 1. Well, again, I square it, so I'm going to get 4 equals y minus 1. Add the 1 to both sides, and y is 5. So when x equals 2, y equals 5. All right, 3, 4, 5. And I know it's supposed to look like, so that helps me a lot to know what to graph. But I'm going to go ahead and connect some of my dots here, and that's what the graph looks like. All right, well, that's it for today. All right, so there you go.